Welcome to another video. Today I will show NDWI, that is normalized difference water index, how to calculate this, and I will start from the very beginning step by step. At first we download imagery from Copernicus. This is raster image, and you can download any raster image from this Copernicus browser.dataspace or copernicus.eu. I think we can skip that part because it's very easy to download, and interface is there. You have to sign in for downloading this range. Here Sentinel-2 and L2A, and cloud coverage is 25%, and I used the data range 2022-25 range, and this is my study area. After downloading the data, we open the QGIS software and raster image, add layer. This is start raster, and from the last raster image we add the data in our interface. So already we downloaded that data is here, Sentinel-2, and you will find the data like this, ASP2, and we can go to granule, and here this and image data. Then we can use any, there is 20 meter resolution and 10 meter resolution and 60 meter, so we can use this data. And for this NDWI index we need band 4 and band 8. This is band 4 in Sentinel is green band, and band 8 is near infrared. So these two we need basically, and we open that data in our interface and we close this, and this is the data. So at first we can rename that because it will be good to work. So at first we rename it is band 8, and here is band 4. This is for near infrared, and we can rename it. It's so near infrared, and this is green. So this is for green. Okay, so these two data we have, and now we need our study area. So we need to add our vector layer study area. So add vector layer from the layer panel, and this is, and vector layer is here. So at first we need to go QGIS, and then our challenge. So this is the study area here, and study area you can download from the any map or any. This is the Bangladesh map, and we can export this from the diva.org. In that website you can download any administrative area or any location map. So this is our location map here, and you can see this, there are 4 different section. So this is our study area basically, and we can resolve this to make it one single location. So in that case you need to do like a vector and a geoprocessing and dissolve. This is the function here, dissolve, and you can see here the study area. This is our the vector map, vector layer, polygon, and selected feature. We have this, like all that. Selected means all, we need to select that. Yeah, then we can go this vector process, dissolve, and we can check the selected feature and run directly, and it will complete. So this is the one single vector layer, and we don't need this layer, so we delete that one. So then we can rename as a study area basically, depending on study area, study area. Okay, so this is our study area and this is still temporary file, so we need to make it permanent. So export, save as feature, and we just name it as study area, like study area, study area. Okay, so we can keep it as it is, and projected coordinate reference is the default one, so no problem, we can run this. And study area, so this is the temporary file, we don't need this, we can delete that one. So these are the three main layer we have so far, and now we have to clip that part, because you can see this raster image is too much, we don't need outer part, we need only this section, so in that case we need to clip. So to make the clip, we need to raster extraction here, basically depending on the vector layer. So clip raster by, so this is our study area, and input layer must be green, or we have to do the both for both layer. So at first we do for the green layer, and this is the mask layer, should be the study area, and we can keep the resolution in the raster same as, and we do the run. So there is some error, unable to open EPSG support file. I think it's no problem. Okay, so this is already clipped here, the mask layer, and we can rename this layer as a, and we can make it permanent, because these layer also in the same way we can do for the near infrared band. That means we can clip the same way like this, and this is for the green band. Now we can calculate NDWI and NDWI index. NDWI index is calculated from the raster calculator. So here we can see that two band is appear here, raster bands B41 and B8. So we know NDWI index is green minus infrared divided by green plus infrared. So B4 is green, so we can double click at, then before that we need to bracket, inside the bracket we can do that. So double click, so only one times, so minus B8, so this is infrared, and divided by bracket close, and inside the bracket we can do green, double click, green minus green plus near infrared. Here still we don't see any options is active, so we need to name the output layer, so that would be the name of NDWI, and we can save it, and we decided the folder name. Now we can see that button is active and expression is valid, so we can click here OK, and calculating the raster expression for the NDWI. So here we don't need basically this two, and we can see the number, the value here minus 0.63 to 0.16, and we know the value greater than 0 is vegetation, sorry, greater than 0 is water body. So in that case we need to calculate again to see the water body raster calculator, and you can see raster band here again, NDWI, this is our newly created index, and here we double click this one, and greater than sorry, it should be here, greater than 0. And then we need to write the output file, and this is water body. So we can click here or say OK and then click OK, and that's the final product. We can uncheck that one. You can see the number 0 and 1, and we can change the pseudo band color to colorful one, and here we can recalculate or reclassify it with equal number based on true, because we need only water and land vegetation. So already you see is already classified. Here we can write this is value 0, so it means it's land or vegetation, and this is water body. Okay, and we can close it, or we can design it based on our style, whatever we like. Depends on your style. You can make it very beautiful. Okay, we can close it. Now we need to export this map using print layout. So where is print layout? That means a test. Suppose test. Okay, then we can click this plus sign and make it, and this map is very small, so we can see the scale here. You can change the scale to 5, or if you want to make more, zoom in, so it is better too. And here you can move this button, you can move inside the map. I think this is okay. Now we want to add another map here. So this map we need to lock that one, and we need to lock this map and try to add the base map, that means the initial map, raster map, the initial first one, the downloaded from Sentinel to check how we prepared that data. And in that case we need to go the folder here, the granule here, and the image data, raster, and the b4. Okay, that one. So that close. Here, this is the map. This is the raster map we downloaded from, and now we need to refresh this one or add a new map here. Yeah. Okay, we can move a little bit slightly. Now we can design this map. We can add the scale here and north arrow pointing north direction, and we can add legend also. Legend is here, we can add legend, and we don't need too many legend here, only one. We need only the inside the map, whatever that is. Okay, you can move a little bit up. Okay, water body is this, color indicates water body and 0 indicates gray band. We can rename here though. Okay, you can customize based on your style, and we can name it as a water body or NDWI, index map, and you can choose the font from here. You can enlarge the font size suppose 20, and you can make the site vertical and make it like that. And the map background we can change, not white, little bit different color depending on your style, whatever you like. Now we can lock that item. So I think this is okay so far we did. And now we can export. How to export? We have three options, like as an image JPG format and PNG. This is vector file HVG, and this is PDF. Also, this is vector file. So we can do any one. Let's do for test NDWI NDWI map. This format is JPG. Okay, we can replace because we have already before we did. This is 300 dpi, and we can save it, and we can see our map production here. We can double click this and we can see how it looks like, and you can see our final product is here. This map is clearly showing. This is which we forget to add arrow marks here. Okay, thank you very much. I hope you enjoyed this video and you have learned how to do NDWI, that means normalized difference water index from the sentinel data of band 4, where band 4, that means green, and we are infrared. Thank you, bye bye, take care.